In this module, we will talk about Google Cloud Platform. So in the previous modules, we learned about AWS and Azure and what the basic constructs are and how the networking and security looks like in there. Now we will look into Google Cloud Platform. So if you look at the hierarchy, notice in the bottom, I'm showing you resources here. This is where your virtual machines, your storage, and other resources are. Now, all these resources are part of project. You can think of it as accounts in AWS. So you can create a number of projects, and within the projects, you can create resources, virtual machines, VPCs, your GKE clusters, and whatnot. Now you can also create a folder structure where you can club these projects together. So for example, team A might have project one. The product one team could have a project two or a project three as part of this folder structure. So this is your way of organizing your resources in a meaningful way. Now, if you look at top, this is where the organization is. This is where your company domain reside. And within the organization, obviously, you will have all the resources, different teams, and that's how you're going to deploy and consume your resources in GCP. In GCP case, they have different cloud products. Like any other clouds, they have networking, they have tools for developers, storage, compute, and whatnot. If you look inside these products, you will find various services. For example, you're looking at the compute product, and within the compute product, you see a bunch of services. For example, the compute engine or Kubernetes engine. In the compute engine is where you will see your virtual machines. You need to peek into this area and see how your virtual machines are deployed. And not only virtual machines, but when it comes to actually building the network, you need to go look inside the virtual machine and see how the connectivity is done. Since we are in the topic of connectivity, let's take a look at this networking product within GCP. Now, in this category, you have, again, a bunch of different services. You have your VPC network, you have your hybrid connectivity option to connect GCP to on-prem data center or branches, and some other networking services. So if you double click on the VPC network, this is where you see the VPC itself. So this is where you will create the VPC, the wall garden for your application, and will define a route table, the firewall rules, and if there is a need to connect or peer VPCs together, you are going to do that from within this area. Now in the network services category, again, you find typical options similar to what you have seen in AWS and Azure: load balancer, DNS, CDN, NAT functionality, and all that you need to provide networking services for your workloads. So what are the important services and resources within GCP that you will be dealing with a lot? The first one I mentioned before is virtual machine. This is where your workloads are running, your applications are running. You can deploy virtual machines, Linux or Windows or other options that you have in GCP. IAM is extremely important to protect your workload and access to those resources through identity and management system. VPC, we already talked about. You need to create the VPC to start building your private cloud or your networks in GCP. Storage is very obvious for your storage needs. Interconnect is very interesting, and you should pay attention to this because this is equivalent to AWS Direct Connect or Azure Express Route. It allows your cloud GCP to connect to on-premise with a private connectivity. So it's a private circuit that you purchase from the colo provider, for example, Equinix, Megaport, and some other providers out there. And they actually allow you to connect your on-premise data center and branches into GCP So then we talked about the DNS, load balancing, and the CDN. So these are the terminologies you need to remember. These are the things you need to watch out for as a networking and security engineer or architect. Now let's take a look at the GCP and how you actually deploy resources in GCP. So the first starting point is the project, like I mentioned before. So you create the project. Once you are inside the project, now you have option to create the VPC network. Now, when you create the VPC network, you provide it a name, and notice by default, it will create the internet gateway and the VPC routing for you. So this VPC routing or VPC router is the router that you have in your VPC responsible for routing traffic between the virtual machines. It's a hidden entity. You don't see it, you don't touch it, you cannot have access to its route table, but it is there. Now, the second thing is the internet gateway. If you recall, in AWS, you have to create this gateway manually yourself, but now it is there in GCP VPC. This allows connectivity back to the internet. If you look at this diagram, I'm showing you two regions here, and this is extremely important to notice. Why? Because in AWS, when you want to create a VPC, the first thing you do, you go to your region and then you create the VPC. That's not the case here. VPC is a global construct. So that's the reason it is sometimes called the global VPC as well. Once you have this VPC, you can create the region, and within the region, you can create your virtual machine. And this VPC can now span across the whole planet because technically you can create a bunch of regions and start putting your virtual machines there. Now, this might not be the desired outcome that you need, so you have to be really careful while you are doing that. So now you have your virtual machines deployed within the region, within two different regions, and they are actually talking to each other without you doing anything through this VPC routing. If you need to control the traffic flow between these virtual machines, you have option to create the stateful rules. GCP calls them a firewall rule, but they are equivalent to the security group in AWS. So now let's talk a little bit more about VPC network and subnet. The first thing you need to remember, unlike AWS, the VPC networks don't have a top level seeder that you would define in case of AWS. So the ranges are actually defined at the subnet level. And when you create a VPC network, you can create one or more subnets. When it comes to actually creating those subnets, you have two options. The first option is to use auto mode. So when you pick auto mode, GCP will automatically create subnet ranges for you in all the regions. But remember, this is not the best practice. Especially for enterprises, you should not do that. Why? Because you don't have any control over the IP ranges that GCP would create for you in the auto mode. So the best practice is to always use custom mode, and then you create the subnet as needed based on the workload that you are going to deploy. And when it comes to creating those subnets, our recommendation is to create those VPCs that are bound to a specific region. It's important that you do not use the global VPC because then it poses some restrictions or caveats there. In some cases, it is okay to use the global VPC, but you should know what are the pros and cons of using a global VPC. Let's take a look at the basic GCP networking component. So we talked about the project, we talked about the VPC. By default, when you create a VPC, that's global in nature. There is no knob which you turn on or off that will make it a global VPC or whatnot. And then you can actually create different subnets. You can define your virtual machines in the subnets or in different regions. What about when you create a number of different VPCs like that? Can you peer them together? The answer is yes, you can definitely peer them together, but remember that the peering is non-transitive. Okay, so that means if you have 3 or more VPCs, if they all want to talk to each other, you have to create a full mesh. The routing is happening by default for you, so you don't have to worry about that. The VPN gateway is a component or construct that you would use when you want to connect your VPC to the on-prem world. And remember, it only supports BGP. Okay, so when you need to talk to the internet, how does it work? So basically, remember I mentioned to you before the internet gateway that is already there. So as soon as you assign a public IP to your virtual machine, they will start talking to the internet, provided you have the proper ports and security group or the firewall rules open to do that. All right, so this is what you need to remember, that the global VPC, although it's really powerful, and this is a benefit or advantage that a customer would have if you compare it with AWS. In AWS, the VPC is a regional construct, but here it's a global construct. It is possible to create your workload across the globe within a single VPC. It does not mean that you should do that. You should look at the design requirements that you have or your business requirements, and based on that, you should go with this model. One challenge that you might see with the global VPC is a massive blast radius. So imagine a VPC which is spread across a planet. You have workload in US West, in Europe, and some in Asia Pac. If for some reason one virtual machine is compromised or is started behaving badly, then potentially it can impact your entire VPC across the globe. The second thing is about the policy-based segmentation. So if you create a massive VPC and you put all the workloads there, pretty much all your eggs in one basket, your prod, your non-prod, your dev, your test, then how would you create the segmentation for those workloads? Your only choice at that point is to create the layerful, stateful firewall rules, which could be very cumbersome. The best practice is to create a VPC for your prod, then a non-prod, then a test, and then obviously you could have multiple prods and multiple test VPCs, and that's how you can apply a proper cloud segmentation or policy-based segmentation for your workloads. With the global VPC, next generation firewall service insertion is not possible, because what happens that when you are trying to insert a next generation firewall into your flow, and if they're sitting in the same VPC, you cannot do that, because at that point, the VPC route table will dictate and will just send the traffic to the virtual machine sitting in the same VPC. So for that reason, again, it's very important that you create multiple VPCs based on the workload, based on the business requirement, and then you connect them together with a proper hub and spoke transit-based architecture that also allows you to insert the next generation firewall or other services into your traffic flow in a policy-based manner. Encryption is very important to remember here, and this is what you can also find on Google documentation, that the data that you have within the VPC is encrypted as at the best effort level. Okay, so just imagine you have one global VPC, you have prod, you have dev, you have non-prod, and all type of workload, and then the encryption is not happening between those. Again, the proper architecture is to create a dev or non-production or prod VPCs, and then when they want to connect to each other, you have proper encryption between them so that your workload is protected and isolated. The last point I want to highlight is that if you're building your architecture based on the global VPC, it's not a multi-cloud design, because the other clouds, they don't follow this model. So it's going to be very different for you to run and manage your VPC design in other cloud, because it's going to look very different than GCP. All right, so let's talk about the GCP design best practices. You should create multiple VPCs based on the type of workload, and those VPCs should be region bound. Why do we need that? Like I said before, for proper segmentation, to provide encryption between the workload when they're flowing and or talking to each other, and for service insertion. For that, if you look on the right-hand side, this is not just what we are saying, but this is what also recommended by Google, that if you need to create networks for different teams with shared services in a common VPC network, you can meet this requirement by creating VPC network for each business unit. And then down below, you can also see that when you are about to create a VPC for different team or for different network resources, you should consider creating more VPCs for your workloads. Now let's move on to GCP shared VPC. It is very much common to have a GCP shared VPC design. Let's take a look at the use cases. So when it comes to providing a centralized control for your networking resources, like your subnets, your routes, and firewall, you would want to use a shared VPC. Why? Because it actually improves the security by restricting network resources to a centralized networking team. So what I mean by that, basically, if you look at this diagram, there is a central IT host project. Basically, it's the project owned by the central ID in majority of the cases. And then the central IT will create the VPCs for you. When you're sitting in your project, and I'm calling it a service project because this is like a tenant project, the central IT can check out the VPC to this project, right? So the VPC that you see here in this project was actually created in this central IT host project, and it is being shared to different projects based on the requirements. So you create a project, and then within that project, you just enable the shared VPC. So when you're creating a project, there is no knob that says, okay, I'm creating a host project. It's just like any other project that you create. A service project, what it is, it's basically a project that is attached to a host project, and then it is given the VPC or subnet resources by a shared VPC admin. The requirement is that all these VPCs must be in the same organization. So you cannot share these VPCs across multiple organizations. And one service project can only be attached to a single project. So you cannot have a situation where this service project is attached to the central IT host project, and then the same can also be attached to another host project. Oftentimes, what I have seen customers are confused about the functionality or the option it provides. Sometimes they think that it is actually a replacement for the transit gateway or transit architecture, which is not true. The shared VPC has no control plane or data plane. It is basically an IAM construct. It's about centralized T checking out resources to the service project. Also, you should not confuse this shared VPC with the shared services VPC, because oftentimes in AWS, for example, you create a VPC, you name it a shared services VPC, where you put your shared services like logging or management type services in there. That's not the case here. Now let's talk about Google Cloud Interconnect. Like Direct Connect and Azure Express Route, Google also provides a private service or a private circuit to allow on-premise resources to connect to Google Cloud. Now, these on-premise resources could be data center, could be a branch, or could be a colo location. There are two types of cloud interconnects. One is called the dedicated interconnect. With this connection, you can connect your on-premise networks or servers or firewalls to your Google Cloud VPC network by using a dedicated fiber connection to your equipment. There is no middle equipment required here. So you can order 10 gig or 100 gig pipe for this service. But the second one is called the partner interconnect, which actually allows you to pick and choose different throughput or sizes for this link. It can start from 50 Mbps and can go all the way to 50 Gbps. But now with partner interconnect, you see we have a service provider in the middle that you need to work with. For example, Equinix, Megaport, AT&T, and others. You connect your on-premise network to your service provider, and then service provider will provide you this connectivity back to Google Cloud that will allow you to connect to the GCP VPCs or the workloads out there. You can provision layer 2 or layer 3 connections. Both of them are supported. And with both options, the dedicated and partner interconnect, you can spin up multiple VLAN attachments in order to provide redundancy and high availability. One thing you should notice that with Google Cloud Interconnect, in both cases, encryption is limited. Now, when you look at the partner interconnect, there is a middleman involved there. It's extremely important that you should think about providing encryption for your Google Cloud Interconnect circuit. Next is compute engine, or the virtual machines that you can deploy on Google Cloud to run your applications on. You can deploy different sizes for those virtual machines, all the way starting from a very tiny shared core VM to a massive virtual machine with hundreds of cores, terabytes of RAM, and the storage options available. When you deploy a virtual machine, remember, it's deployed in the availability zone within a specific region. And you can also use something called managed instance group that would allow you to scale up or scale down your virtual machine based on different policies and requirements. The compute engine virtual machines are zonal in nature. And the most important thing to remember that once you add NIC to your virtual machine and you deploy this virtual machine, it's not possible to remove or add a new NIC to your VM. So it's extremely important that you size your machines accordingly in terms of NIC availability. Another restriction in Google is that if you deploy a virtual machine with multiple NICs, let's say 3 NICs, each and every NIC should belong to a unique VPC. You cannot have a virtual machine, let's say with 2 NIC and both NICs landing into the same VPC. That's not possible with GCP. And the maximum number of NIC you can support per virtual machine is 8. When you're building your networks, there are some constructs provided by GCP in order to secure your virtual machines and workload, but you should consider deploying third-party firewalls like from Palo Alto or Checkpoint or Fortinet to enhance the security posture for your network or for your workloads. Now, when you deploy these virtual machines in your projects, in your VPC, typically they're deployed with multiple NICs. And like I said before, with the virtual machine, you can only have up to 8 NIC. So in a topology where you're deploying a third-party firewall, remember that you can connect only up to 8 VPCs to that virtual machine. Typically, what we recommend is that you deploy this third-party firewall virtual machine in a security VPC or a transit VPC, and then have other VPCs connected to it and create a policy so that you can send the traffic to this third-party next-generation firewall for deeper inspection. All is good, but you have to also remember that when you are working in the context of a global VPC, then you are restricted in terms of using these third-party next-generation firewalls. Why? Because just imagine you have a one large VPC, a global VPC, and then you have workloads or virtual machines deployed across different regions. Now, when you put this same virtual machine in that global VPC, first of all, like I said, only one NIC of that next generation firewall can connect to this global VPC. And the second limitation is that when, let's say, virtual machine in subnet 1 wants to talk to virtual machine 2 in subnet 2, and you want it to be inspected by the firewall, you cannot really do that. Because at that time, the local routing will take precedence and your traffic will just be routed between these two subnets or between these two virtual machines. There is no way you can actually insert a next generation firewall in that single global VPC. If you want to use managed instance group for your next generation firewall, again, you are limited because the managed instance group is a regional construct. It's not a global construct. So you cannot really use it in a global context. If your third-party firewall or next generation firewall insertion design requires VM with multiple NIC, remember the maximum count is 8. And once the NICs are connected to the virtual machine, once you deploy this next generation firewall virtual machine, you cannot add any more NICs to it. You can argue that VPC peering can be used to increase the number of VPCs inspected, but remember VPC peering has a limit of 25 only. A lot of customers, when they're deploying their workload, traditionally they were using the virtual machine, but now to use GKE or Google Kubernetes Engine. And this is also true for across other clouds. Obviously, every cloud has their own flavor of Kubernetes. In case of Google, we have GKE, which actually provides a managed environment for deploying, managing, and scaling your containerized applications. There are specific components within the Kubernetes system that can be managed and backed by Google. The node lifecycle itself is managed by Google. So for example, auto scaling or update type of activities can be performed by Google automatically. If you look at the networking for GKE, GKE offers two networking modes for node to node or for pod to pod communication. The first one is called the VPC native networking, and the second is route-based networking. Route-based networking is something Google does not recommend anymore. You should pay attention to the VPC native networking, which is the GKE default and recommended by Google. When you're deploying your node and pod, they need obviously IP network, but how do they get the IP address? The nodes are taking the IP addresses directly from the VPC CEDAR or CIDR range. The pods and services are using the IPs from the secondary IP range. We also call them alias IP ranges or alias IP addresses. When you deploy your workloads, your virtual machines, or your next generation firewalls as a virtual machine, you need load balancing services so that you can balance the load between those virtual machines. Typically, the target for the load balancer is a virtual machine, but other endpoints are also supported. There are a number of different load balancers or options provided by Google based on specific requirement. For example, if you have HTTP, HTTPS type application that you want to load balance, you will use the HTTP load balancer, which is basically unlike AWS and Azure. It's very different the way it works in GCP. GCP load balancers are fabric level services. They're not like ALBs or app gateways in Azure that is basically deployed in your respective VPCs or VNets. When the traffic comes from outside, the source IP is changed to the Google public IP in case of HTTP or HTTPS load balancer. This load balancer is available in global or regional setting, and you can use it for your external or internal designs. Since it is HTTP, HTTPS, obviously the port support is limited, so you can use 80, 8080, or 443 ports. This load balancer also supports Cloud Armor, WAF, Web Application Firewall, or CDN services. Now, if you have your applications, the non-HTTP or HTTPS application, typically you would go with the TCP/UDP layer 4 load balancer. This is available for your external and internal designs, but remember, this is a regional construct. This load balancer supports all ports that you can use with your firewall or with your routing appliances. The third one is called the TCP/SSL proxy load balancer. This is external load balancer and globally available. It has a specific list of port it supports. And again, when the traffic is coming from outside, the source of the IP address will be changed to the Google public IP address. We discussed about Google Cloud Interconnect, which is a private circuit to connect your on-premise resources to GCP. What about if you don't have that option, or if your resources are sitting somewhere on the internet and you want to connect it to Google? Now you can use the Google Cloud VPN, which basically allows you to build the IPsec tunnel from your on-premise router or firewall to GCP. They used to have something called the classic VPN, which is deprecated now. And now the only option available is called HA VPN or highly available VPN. This actually allows you to connect your external firewalls, routers, using IPsec back to GCP. And once you have this IPsec established, you can also run BGP on top of it so you can exchange routes dynamically. These remote devices or routers could be sitting in data center or a colo location, or you can also build this IPsec connection back to another HA VPN gateway or to other clouds. For example, in AWS, they have VGW, which is their VPN service. You can also build tunnels back to those clouds as well. An important limitation you should be aware of is that HA VPN gateway cannot connect to a virtual machine running inside GCP. When you deploy the HA VPN gateway, by default, it is deployed as a pair. There is a highly available mechanism behind the scene. On the surface, you get the two public IP addresses that you use to build your IPsec tunnels to. And you can build multiple IPsec tunnel to the public IP address. So you can actually create a full mesh or a crisscross type connectivity so that one link goes down, you have other links available to provide you high availability. When you deploy your applications, your workloads in your VPCs, they have a requirement to connect to various Google services, such as Google API, SQL, or serverless. Now you can use public access to connect to Google APIs, but some enterprises, they mandate using private RFC 1918 access to connect to them. They don't really want to go onto the public internet and consume those services. You have an option to connect to your virtual machines or your VPCs to these Google offering without using public IP addresses. So you can connect to Google APIs, you can connect to Google services, or you can connect to Google serverless, such as Cloud Functions, Cloud Run, or App Engine using private connectivity. There are different features given to you by Google in order to achieve that requirement. The first one and the most important one to remember is PSC, Private Service Connect. This is like AWS or Azure private link, which provides private endpoint that you see in your VPC, and then there's a private IP address that you can connect to and consume services this way. Services are created by publishing a PSC endpoint that is attached to an internal TCP or UDP or HTTPS load balancer in the background. You can access those services directly from the VPC, or if you have a HA VPN, you can also use that to connect to those services. Interconnect, Google Cloud Interconnect and peering are not supported with PSC. The second option is called PSA, Private Service Access. It's the old model. PSC is now preferred. What it does basically, it uses VPC peering mechanism to connect to a Google managed VPC, and this is where you will have your application or service deployed. Now, the challenge is that all the limitations that we have with peering comes into picture here. For example, the transitive routing to another peered VPC is not supported with this model. The routes from the other VPCs or data center, they must be propagated, or your traffic should be NATed to an internal IP address on the consumer or the customer VPC side. PSA can only support specific services such as Apigee, Cloud SQL, and this does not work for the Google API connectivity. The third option is called PGA, Private Google Access. It uses the default internet gateway to connect to Google API and Google services, but it does not require the virtual machine to be sitting on a public IP. So they use a special mechanism to connect to the Google APIs and other services using the default internet gateway, but without requiring the public IP address assigned to your virtual machine. And then we have this special case, which is about connecting your VPC to your serverless. And they have created a specific connector for that. They call it serverless VPC connector. It can only be used for serverless applications. So what are your design choices when you want to connect to the Google APIs or other Google services on private link or using private RFC 1918 IP addresses? Let's say if you want to connect to Google APIs, your option is that you can use PSC or you can use PGA. They both support most Google APIs and services. But like I said before, PSC is preferred. You should consider configuring your DNS properly so you can send traffic to this PSC service. When you configure or deploy a PSC for Google APIs, it can be accessed from on-prem or a peered region. But like I said, assuming you have proper DNS configured for that. PGA can be enabled at the subnet level for VMs without public IP address. Now, what about connecting to the other Google services? You can use PSC and PGA for that. They both support most services offered by Google, but PSC is preferred. You can use PSA too, but it supports only some Google APIs or services. And in order to connect to your serverless, your only option is to use something called VPC connector. Google Network Connectivity Center. Google released this service which allows on-premise branches or data centers to connect to GCP in a seamless fashion. We mentioned before, Google already has Cloud Interconnect for private connectivity, like a private circuit, and then the HA VPN option to connect your remote sites, branches, or partner into GCP But then if you want to provide connectivity between these on-premise resources, you have to do some manual work. So Google gives you this NCC service, which allows your on-premise resources to connect to each other. It follows a hub and spoke model where GCP NCC hub is a construct that you configure under hybrid connectivity option when you log into the GCP console. And then you attach your either Google Cloud Interconnect or your branches to this hub. And then you get this any-to-any connectivity between your on-premise resources with this service. These connections are called spoke in the context of NCC construct. Another option is to use a third-party virtual instance or virtual machine that you can deploy in VPC. NCC calls it a router appliance. And once you have this router appliance deployed in NCC, you can pair it with Google Cloud Router and then can exchange BGP routes from these on-premise resources back to your Google virtual machines or Google services. There are some limitations with this design. The same VPC network must connect all spoke to the hub, and this service is not multi-cloud. Next, we will cover OCI Networking 101.